Hi, my name is Winsol, and today I'll be explaining the seventh assignment of my computer systems design class, where I want to see the effects of virtual memory by writing a simple program with tables. So what I want to do is to load in some values inside the main memory and add up all these values in this 12 kilobyte memory space. And I want to see how changing the mapping of the virtual address to physical address changes the sum. Okay, at first we want to disable the memory management unit because we want to do flat mapping so that we can store the values in specific physical address. Okay, so we just run this block of code, we just disable the MMU so that we won't use page tables. Okay, in here we just want to store the values we want. This store negative block of code right here stores negative 1024 to negative 1, starting from the address 0x400000. Okay, and this block right here stores positive 1 to 2048, just like the one shown right here. Okay, and then we just run the block of code. Okay, and now we want to see how the page table changes the value of value of the sum. So we want to create a page table number 1 that looks like this. It maps the virtual address 0x200000 to 0x400000. So to do that, we go to the first level translation table. Okay, for the first section or the first megabyte is flat mapped, so it's equal to the physical address. The second section or the second megabyte is flat mapped again. However, the third megabyte is mapped to 0x400000. Okay, and we reference the level 2 page table right here for the kilobytes for the small pages. Yeah. Okay, and in the second level page table, for the first kilobyte, we want to map it to 0x400000. Okay, and the second kilobyte this address, and the third kilobyte to this address, which is shown right here. So the first 4 kilobyte is mapped to this, second kilobyte is mapped to this, third kilobyte is mapped to this. Okay, which is how the page table number 1 looks like. And we can run the rest of the code down here. Okay, we want to enable the MMU so that we can use the MMU table for virtual address to physical address translation. Okay, and this block of code right here just adds up all the values starting from the start address to the end address. Okay, and if we run the code, we are expecting a value that the value we are expecting is 1 from negative 1024. We add up all the values up to 2048. Okay, which is 1,573,376, and I think it's probably correct. Okay, and we want to try the page number 2 right here, so we will change up the mapping a little. So the first kilobyte, 4 kilobyte, is mapped to 0x400000. The second one is mapped to 40200000, and the third one is mapped to the first, just like the first one. For that, I just changed some mapping inside the level 2 translation table to this way to reflect the changes that we made in page number 2. Table number 2, and if you run the code, we will have a different value for the sum, which is 523,776. So the reason why that happens is because the virtual address for the first 4 kilobyte is mapped to the physical address, first physical space right here, which is equal to negative 1024 up to negative 1. Okay, so we just add all the values right here, these values, and the second one is mapped to this third 4 kilobyte space in the physical address, which is from positive 1025 to positive 2048. However, the third 4 kilobyte virtual address or virtual space is mapped to the first 4 kilobyte in physical space. So we add another negative 1024 up to negative 1. So it's smaller than the flat mapping.